Hi, and welcome to the introduction of the Brain-Computer Interfacing Week of the course Biosignals in Medical Electronics for Creative Technology. My name is Femke Nijboer. I'm an assistant professor in the Biomedical Signals and Systems groups of the University of Twente. You know me from Module 3 in the first year, and I'm very happy that I can teach you about one of my favorite topics, brain-computer interfaces. But first of all, what are brain-computer interfaces? What do you know about them? We try to measure thoughts in your brain, and we try to turn them into actions, into commands for a computer. How does that look like? I'm going to show you one application of a potential use for young school children, how we can measure their attention levels in class and then give some information to the teacher. This is an experiment from China, just a short break. I'm going to turn off my camera so you can view it.
红色是表示你的专注力显示的很高，
Teachers at this primary school in China
蓝色是走神了，
know exactly when someone isn't paying attention.
白色就是你可能跟网络还没有连接好。
These headbands measure each student's level of concentration. The information is then directly sent to the teacher's computer and to parents. China has
What I would like to achieve with you in week 4, next week, is two things. I want you to be able to describe and explain the main components of the processing pipeline of a brain-computer interface. And I want you to be able to conceptually create a novel design of a brain-computer interface application. So we have a more theoretical part, an objective, and we have a more creative aspect for next week. How do you prepare for the classes next week? We have a lot to do, and I need you to do a lot yourself so you can use me as your question and answer person. What you need to prepare is you have to read 2 papers, which I've already put online on Canvas. Then I will also place screencasts like this on Canvas so you can prepare yourself and watch mini lectures before you come into class. I will also upload some additional videos and give some links to the Khan Academy, where you can find more information about the brain or about brain-computer interfacing and neuroimaging techniques. Then on Monday and on Friday, there will be certain time periods where you can have 30 minutes with me to have question and answer sessions. And then I really need you to be prepared and to come into class and ask me lots of questions. We can use 2 communication platforms. One is the big blue button that you already know from Canvas, where you can post you can type your questions in there, but also ask me questions through audio. And we can use the Slack, which I haven't installed yet, but I'm thought to believe that you are already using it. Okay, so let's go to the principles of a brain-computer interface. What is this processing pipeline that I want you to know about? I'm going to take you through it in various ways, but this is one way. Imagine we have a brain, and within the brain there is all kinds of activity going on. The brain activity is chemical and it's electrical. And it's mostly the electrical impulses that we can measure very well. You've heard about this in lecture 2 from Eric in the past 2 weeks. Now we need to record this brain activity somehow from the brain. And one way of doing this is, for example, I'm just giving one example here, is the electroencephalogram, or in short EEG, which looks a little bit like this. You have a couple of channels here, 1, 2, 3, 4, 5, 6, 7, and so on. Number of channels that record electrical signals from the brain. Now, looking at those channels, you see that we can't really say a lot about what a person is thinking, what a person is doing. It's difficult to decipher. But there are some features that we can decipher very well in the EEG. For example, if somebody has his eyes open, if somebody is awake, then the EEG signal would look like this. You see high frequency, lots of spikes. Whereas when somebody is asleep, you see more larger waves and slower wave. So lower frequency and higher amplitude of the power of the rhythms. Okay, but this is still not a brain-computer interface input signal that we can use. We want to voluntarily give a command to a device. So what do we need for this? We have a couple of tricks from neuroscience that we know about. Because if you make certain kinds of mental imaginations, if you use your imagery, you can induce brain patterns in the EEG. For example, if you use the imagination of moving your hand, for example, your left hand, or if you think about moving your foot. Now, these two different types of activities in your brain cause different signals in the EEG. And we can decipher which one you're thinking about with a brain-computer interface. And if we can do that well, so if we can predict, is this person thinking about hand movement imagery or about foot movement imagery, then we can also send commands to an application. And in the next week, I also tell you about different kinds of application. One application that is often mentioned is a neuroprosthesis. That this guy is operating a robot arm here behind my video, and he's opening and closing the hand, the robot hand, with the power of his brain. Isn't that cool? So that's the brain-computer interface cycle. For the assignment and for my learning objectives, I'm going to take you through some of the sub-goals that I have with you, so you understand better what I want you to learn in the next week. The first is that so here is the brain-computer interface cycle as given by Marcel van Gerven, and there is a paper on Canvas that I really need you to read. And it starts here with the user. So we measure activity from the user. What do I want you to learn about this measurement? You have to be able to list and explain neuroimaging techniques that can be used for BCI. And I would like you to be able to evaluate the techniques based on the location of the measurement. Is it inside or outside the skull? What is the temporal versus the spatial resolution? What are the risks of the different measurement? How efficient is it to use this type of measurement? And what are the costs of the measurement? More or less, not exactly. Okay? Then a next goal is that I want you to be able to list and describe the most common types of pre-processing that you can do with the data that you collect with the measurement. For the feature extraction, I want you to list at least 3 EEG features, signatures that can be used as input for a brain-computer interfaces. I want you to be able to describe which kind of stimulation tasks you need to elicit such EEG features in a user. And I'd like you to evaluate the pros and cons for using particular features. And this is a lot to ask for, so you need to do quite a bit of reading on your own on this. And ask me questions when you have the chance. Now, I'm a psychologist, so I'm not very good at prediction, because machine learning is the scientific field that you need to know to do prediction. But you get this plentiful in other courses, and also in the master programs, there are several courses. So we can discuss which courses you can take later on to obtain this skill. We also speak about output. How do you give feedback to the user, and can you do that in a continuous or in a discrete way? You need to understand the difference between those words. And finally, we speak about different brain-computer interface applications for disabled users as well as healthy users. And a final, quite easy goal is I want you to be able to name at least 3 big tech companies investigating brain-computer interfaces. Think about Neuralink from Elon Musk, Facebook, or Microsoft. You already have 3. Okay, so those are the sub-goals for the first learning goal. Now, for learning goal 2, I want you to conceptually be able to create a novel design of a brain-computer interface application. This is related to the second assignment, which is an individual assignment for all of you. You have to invent an application for a brain-computer interface. This is the creative part, and I'd want you to describe it to me as best as you can, and very visual if you want, some idea of how we can use BCI in an application in a creative way. Okay, we're almost done. A couple of things. How do you prepare for next week? There are 2 papers online that I want you to read and ask me questions about. And the first is the most important, I think, from Marcel van Gerven, the brain-computer interface cycle. You see it here. And I want you to read these papers, and I'm not sure how used you are to reading scientific papers, but you'll find that maybe it goes really slow because there's a lot of words in there that you don't know about yet, a lot of concepts that you don't know about yet. We use a different kind of terminology, but it can help you to train yourself to what you want to ask me. So my suggestion is, if you go through this paper, and I'll show you the next page, please annotate every part that you don't know about and that you want to ask me. For example, here is the sentence: in BCI technology, covert mental activity is measured and used directly to control devices such as a wheelchair or a computer, or to modify one's own patterns of brain activation. And maybe you don't understand what is meant with covert mental activity. So write that down somewhere in the paper or the PDF that you're making. Similarly, here is a phrase about completely locked in amyotrophic lateral sclerosis patients. If you say, what do they mean with locked in? Then please ask me such questions during the question and answer sessions, and I can explain them to you. So like this, you go through the whole paper. The second paper is also a very nice overview paper from Shatilov and colleagues from 2019, where they explain how brain-computer interfaces fit in the whole trend of natural user interfaces in mobile computing. So you understand better why we're making brain-computer interfaces and what's interesting about it. Okay, so next week I see you on Monday afternoon and on Friday morning. And during the time slots, you will have some time to do some self-study. So still you can read a bit in the paper or read or view the lectures that I will put online. But there are certain time slots in which I will be online in the Big Blue Button conference to answer your question. And the first time slot, on Monday we will do the following. On 2:45, I will come online to answer your questions about lectures. So the first lectures will be about the introduction to brain-computer interfacing. And then at 3:30, I will give you the explanation of the group assignment there. After that, we take a little break, and then you can ask me questions about the assignment together with your group. It's the same group that you are in now with Eric. After that, you have some more time for self-study, and you can view the lectures, prepare and start working on the assignment. Then on Friday, I see you back online, and you will work with your group on the group assignment. And by then, I think you already have some questions for me about the assignment. So from 9:30 until 10, I will answer about the assignment. And then we will spend some time, an hour or so you can study my lectures about innovative brain-computer interface applications and I will explain the individual assignment. And then in the end, you can ask me, I'm sure lots of leftover questions, and you can ask me questions about the individual assignment. You have to hand in the group and the individual assignment on the 29th of May, and I will look at them then. And there will also be a resit of the group assignment if you have an insufficient grade. And also for the individual assessment resit, you can redo that. I hope this was clear to all of you. And then I would like to thank you for your attention. I'm looking forward to our Frankenstein week on brain-computer interfacing. See you all next week, and until the next lecture.